Very well. So continuing 7.2, hypothesis for the mean standard deviation of population is given to us. Remember that last time we learned that we can find the p-value following the steps and deciding if p is less than or equals to alpha, reject the null hypothesis, and if p is not less than or equals to alpha, we fail to reject the null hypothesis. Another method of deciding about null hypothesis is using rejection region. So another method to decide whether to reject the null hypothesis is to find the standardized test statistic and see if it falls within a range of values called the rejection region. So, rejection region. Definition. A rejection region or critical region of the sampling distribution is the range of values for which the null hypothesis is not probable. If a standardized test statistic falls in the region, then you say that, hey, the null hypothesis is rejected. A critical value, z sub 0. So, z sub 0 separates the rejection region from the non-rejection region. How do we find the rejection region? So, if you have a left-tailed test, the area to the left, you find the area to the left, and then you use your inverse norm to find ZC.
But why have the two different 17.2 is different?
So how do we find critical values in the standard normal distribution? Specify level of significance, alpha. Determine whether the test is left-tailed, right-tailed, or two-tailed. Left-tailed, right-tailed, or two-tailed. Find the critical value or critical values z sub 0 when the hypothesis test is left-tailed. Your z-score corresponds to the area of alpha. So we have our alpha. What was alpha? Level of significance. We use inverse norm to find ZC. If you have a right-tailed graph, find the z-score that corresponds to the area of 1 minus alpha. So if you have a right-tailed test to find ZC and alpha is given to you, you use inverse norm for 1 minus alpha. And if you have a two-tailed test, you can find the z-scores or critical values by using alpha divided by 2 or 1 minus alpha divided by 2. One of them is enough. Why is that? Because you have symmetry. If you have one of them as a negative number, the other digits with positive sign forms the critical value on the right-hand side. So to find ZC, you can use inverse norm of alpha divided by 2. Let me write down the summary for you on the board. Some people find rejection region easier to work with, but in questions, in examples, on the exam, there is no difference between using a p-value or rejection region. So note that some statisticians using rejection region instead of using p-value. Results are exactly the same. There is no difference by rejecting a null hypothesis using a p-value or using a rejection region. So to find rejection area or rejection region, we have three different cases. Remember that. You either have a left-hand graph, your alpha is given. Remember that this area is alpha. You use inverse norm for alpha to find this z value, z sub 0. We call this critical value. So let me write it here for you. By inverse norm alpha. If you have a right-tailed graph, so this is left-tailed. If you have a right-tailed graph, this is the area to the right. This is your alpha. To find z sub 0, sorry, we use inverse norm 1 minus alpha. And eventually, if you have a two-tailed graph, some part of alpha is on the left, some other part is on the right. Remember, the alpha or the level of significance is just the probability. So alpha divided by 2 is on the left-hand side. To find z sub 0, in this case, it's going to be negative. And positive z sub 0, we're going to use inverse norm for alpha divided by 2. Then you say that if the standardized test statistic is in the rejection region, we reject the null hypothesis. If z x bar minus mean divided by sigma times square root of n, or t x bar minus mean divided by s times square root of n, depending on which case is this, is in the rejection area, we reject the null hypothesis. I have some students feeling comfortable using p-value. They don't like rejection region. Some other students feel more comfortable about rejection region, rejection area. Again, on the exam, it doesn't matter which method you're using. Both of them result in the exact same result and conclusion. Let's get back to the notes. So to use a rejection region to conduct a hypothesis test, calculate the standardized test statistic z, or if sigma is not given, you're using t. Z. Let's write down sigma. If sigma is not given, we use T. We're going to talk about it in 7.3 later, but just know that in general, we use T since you have seen T table before. So if this Z or standardized test statistic is in the rejection region, we reject the null hypothesis. If not, we fail to reject the null hypothesis. Either the first one or the second one, not both. So take a look at left-tailed graph. Left-tailed test, Z sub 0 is your critical value. If Z or test statistic, standardized test statistic is less than your critical value, then we reject the null hypothesis. If not, if that Z is inside this region, the white part, you fail to reject the null hypothesis. If you have a right-tail test, the same process. If Z, standardized test statistic, is greater than Z sub 0, it means that your Z is inside the rejection region, we reject the null hypothesis. Otherwise, we fail to reject the null hypothesis. And finally, if you have a two-tailed test and Z is less than negative Z sub 0, your test statistic, standardized test statistic, is less than your critical value, or if it's greater than your critical value on the right-hand side, you reject the null hypothesis. The process is the same. Let's go over one example. You can use p-value or you can use rejection region. It doesn't matter. You can solve it using both of them. Hypothesis testing. Employees at a construction and mining company claim, okay, our claim is given, everyone, that the mean salary, keyword, mean salary of the company's mechanical engineers is less than, another keyword for you, mean is less than, mean is less than, mean is less than. So what's given to you? Is it null hypothesis or is it alternative hypothesis? Which one is that?
Alternative.
Alternative, very good. We don't have equality. Mean is less than that of one of its competitors, which is $68,000. So your alternative hypothesis says mean is less than $68,000. So what is your null hypothesis?
Mu is greater than or equal to 68,000.
Very good. $68,000. A random sample of 20 of the company's mechanical engineers has a mean salary of $66,900. What is this number? Guys, I'm waiting on you. Please write your answer in the chat or unmute yourself.
X bar.
Very good, Elaine. Thank you. X bar is given to us. Assume the population standard deviation is 5,500. So what is this number? 5,500.
Sigma.
Sigma, excellent. Standard deviation of population is given to us, 5,500. And the population is normally distributed, and your level of significance is 5%. Test the employee's claim. Very well. Let us write down this information on the board. Go over this example together. So what information do I have here? I have my very good. Thank you, Fabiana. Sigma is given or not? Hypothesis testing, our very first step. First of all, is hypothesis testing about mean. Testing about mean of the population. So our very first step is to see if sigma is given to us or not. If sigma is given or sigma is not given, which case is that? Do we have our sigma, everyone?
Yeah, we have sigma.
Very good. Thank you. Thank you. I'm reading your chat. Thank you, Jessica. Thank you, Felisa. Thank you, Sunny. Nan, very good. Excellent. Sigma is given. Sigma is given to us. And sigma is equal to what? What is your sigma? 5,500. Thank you, Shana. Thank you. 5,500. What is the next step? After finding to see if we have sigma or not, what do we do next?
Is n greater or equal to 30?
Nice. Is n greater than equals to 30 or population is normal? Which case is this in this example? What is our n?
Population is normal.
Very good. What is our n?
E.
N is equal to
20.
20. Thank you very much. Max, thank you. 20. Is 20 greater than equals to 30? No.
No.
But Adlon, perfect. The population is normal. Thank you very much. Population is normal. What's the next step? Step 2.
Category?
Null and alternate.
Very good. We need our hypothesis testing. Hypothesis testing. Which case is this? Is this the first case that says, hey, null hypothesis says mean is greater than equals to k? Alternative mean is less than k? Or is it the second case, second category, mean is less than equals to k? Alternative mean is greater than k? Or is it the case that two-tailed test? Which case is this?
The first case.
The first case.
First case. Thank you. Thank you, everyone. The first category. Perfect. Perfect. Thank you, Jessica. Thank you, Selena. Fabiana, thank you. Emily, thank you. Nan, perfect. The rest of the class, please participate in chat or unmute yourself. I'm waiting on you. Very good. Thank you there. Excellent. The rest of the class. Thank you, Felisa. Excellent. Guys, I'm not going to move on. I'm waiting for your participation. Everyone needs to learn this step so we can move on to the next section. This is super important. Thank you, Max. Ellen, thank you. Case one, Marvin, thank you very much. Thank you, Jen. Thank you, Olivia. Perfect. Thank you, Edgar. Perfect. Nice. Thank you, Yuchen. Thank you, Vanessa. Thank you, Dora. Vijay, thank you. Shana, thank you. Yajun, thank you. Excellent. Thank you very much. Margaret. Okay. So this is case one. It means that it says our null hypothesis mu is greater than equals to alternative mu less than. So what is K? What is your K? Thank you, Amani. Thank you, Sammy. Thank you, Shana. Very well. Excellent. Very good. Excellent. $68,000. This is your K. $68,000. Perfect. Thank you, everyone. Thank you so much. So what is the next step? Step 3. What is? Alpha. Thank you. What is our alpha? Alpha is how many percent? 5%. Thank you, Nam. Thank you, Sunny. Marvin, thank you. Myra, excellent. Thank you so much. 5%. 0.05. What will be the next step? Now you have two options. You can either move on to the next step, find your Z value, or you can find the rejection region, whichever you feel comfortable with. It doesn't matter. If you want to use your test statistic, Z is X bar minus mean divided by sigma times square root of n. Z is X bar. What is our X bar? X bar is equal to
66,900.
Thank you so much. Minus mean of the population, 68,000 divided by sigma. Sigma is given to us, 5,500 times square root of n square root of 20. So what is this number? What is your Z? Very good, thank you. Almost negative point. Thank you, Nan. The rest of the class, I'm waiting on you. Negative 0.894, perfect. Excellent. Thank you, Fabiana. Thank you, Shana. Alan, thank you. Emily, excellent. Dare, thank you. Marvin, thank you. Vijay, excellent. Sammy, thank you. Olivia, perfect. Edgar, thank you. Thank you, Max. So, negative 0.89. What's the next step? Next step.
P-value.
First, you need to find
The area.
area. Guys, step by step. 5, you need to find the area of Z. What is that area?